The goal of this video is to start talking about inference. Inference is the procedure where we take a sample and we try to infer something about the population. Now, the key to inference is understanding what a p-value is. So basically, the focus of this video will be on p-values. Imagine that I came to class tomorrow with a brand new deck of cards, and it was sealed up in plastic. And I said to you folks, hey, I'm going to come to each person and I'm going to let you, from this brand new deck of cards that you're seeing me open, I'm going to let you choose one card. And the first person who pulls out a red card is going to get an entire bag of Reese's Peanut Butter Cups. That's a pretty good gift or prize. So I go to the first person. Let's get a drum roll. Here we go. I have this set for drum roll. There we go. And they pick a card. And it's a black 5 of spades. They didn't win. Okay, so I go to the second person. Let's just make one of the Dans. And one of the Dans picks out a card and we say drum roll. But no, it's the 4 of clubs. Okay, what happens now? Okay, I go to the next person. Maybe I go up to Bella and I say, Bella, it's your turn. Pick any card out of this deck. And here we go, drum roll. Wow, she has another black card. And then I go up to Darren and I say, Darren, it's your turn. Pick any card. And we have another drum roll. Uh-oh, where is it? There it is. He picks. It's another black card. Then I go up to Emma and I say, Emma, it's your turn. You pick a card. We wait for the drum roll. We pick a card and it's a spade. Now at this point, someone's thinking something. Probably a lot of you are thinking something. What are you thinking? My bet is that you're thinking, wow, it's really unlikely if the deck were fair that we got 5 black cards in a row. And you're starting to doubt whether the deck is fair. So this in your head is a mini inference test. When you do an inference procedure, we start off with something called the null hypotheses. This is basically what I think of as the status quo. It's what we accept. When we started this and I opened the deck, all of you folks were sitting there going, you know what? I have no doubt that the deck is fair. So my null is that I have a fair deck. You're saying Mrs. O'Brien is not a sneaky person. Why would she ever not use a fair deck? But as we're going, some of you are starting to think, she might be pretty tricky. And you might say, hey, I think the deck's not fair. And this statement, which we're going to try to prove, is called the alternative. And the alternative is that the deck, and that is an E there, is not fair. In other words, Mrs. O'Brien is trying to trick you. So, at the beginning of any test, you start off thinking to yourself that the null is true. And we gather evidence and try to say, well, how likely is the null going to be true in regards to the evidence we have? So when you picked out the first black card, its probability of being black was 26 out of 52, or 0.5. Now, at this point, I went to the second person and they picked a card. Now, if you think of their probability, the first person picking a black is 26 out of 52 as a probability. The second one then picking a black would be 25 out of 51, which gives us 245, excuse me. Now, if we go to the third person and we say how likely is it that 3 black cards in a row, we would just have to take this answer from here and multiply by 24 out of 50, and we would get 0.188. What's kind of neat statistically speaking is at some point during this whole scenario, you started getting a sneaky suspicion that I was not telling you the truth. And usually that time is when you have an event that's happening less than 5% of the time. It's just kind of a fact of human nature that as soon as we got past the fourth black card, up until that point, you're like, okay, this could happen. But as soon as you get past that, you start to say it's really unlikely. And this probability of getting 4 black cards or 5 black cards in a row, if the deck is fair, is called a p-value. So at this point, we start to understand that the more unusual something happening is, the more likely we are to doubt the null. If the deck was fair, I had no problems getting 2 blacks in a row, maybe even 3. But the likelihood of getting 5 blacks in a row if the deck is fair is only like 2.5%. I start to say, well, maybe the deck isn't fair. So what we have basically here is we've worked with the null that the deck is fair, and the alternative is that the deck is not fair. And what we do is we calculate what's called a p-value. This is a conditional probability. It's the probability of obtaining a sample statistic at least as unusual as we do, given the null is true. So we're saying the likelihood of getting at least 5 blacks in a row if the deck is fair is very low. It's like 2.5%. That p-value leads us to our decision. I want to stop a second and really stress to you that the p-value is a conditional probability. Again, it's if the null is true, how likely is it that we're going to observe something at least as weird as we've seen? And you just saw the more unlikely it is to happen, the more likely we are to reject the null and think it's wrong. So a low p-value is evidence to reject the null. And what is considered low? Usually in statistics, we consider low less than 5%. Not a hard, fast rule, but it's kind of a rule of thumb. A high p-value is evidence that we failed to reject the null. We're going to say, you know what? This could have just happened by chance, even if the deck was fair. Now, there's something kind of interesting in statistics. We never prove the null is true. I want you to think of a trial. Defendant comes in and he says, for the null, I'm innocent. The alternative is we're trying to prove that he's guilty. At the end of the trial, what do they say if they don't think the person has committed the crime? Do they say they're innocent, or do they say not guilty? We never claim the null is true. We never say they're innocent, because we could come up with more evidence, and that evidence could actually show that the null was false. Think the OJ trial. They found him innocent, but obviously more evidence could have come in and we could have found him guilty. So we never prove the null is true. We never accept it in any form. Here's a great example of that. If the null is X is an elephant, and the alternative is X is not an elephant, what conclusion can you draw if A, X has 4 legs? Well, let's think of the p-value. Given that it's an elephant, how likely is it that it would have 4 legs? Very likely. We'd have an incredibly high p-value. But does the fact that something has 4 legs mean it's an elephant? No. We haven't proven it's an elephant. We just haven't proved it's not an elephant. Now, on the other hand, if I tell you our evidence it walks on 2 legs, well, how likely is it that it's an elephant and it walks on 2 legs? It's not. We would reject the null and say the alternative is true, that it's not an elephant. One final example, just to kind of work through an example with you. Can a smile have an effect on punishment following an infraction? See the goofy smile on the side there? Participants in an experiment took on the role of members of a college disciplinary panel judging students accused of cheating. Reminder, the only way to show cause and effect is with an experiment. For each suspect, along with the description of the offense, a picture was provided with either a smile or a neutral face. A leniency score was calculated based on the disciplinary decisions made. Researchers were trying to establish if the average leniency score is higher for smiling students than neutral students. So in other words, if you smiled, were you going to get a more lenient punishment? A good way to decide what's the null and the alternative is to think about what we're trying to prove. And here we're trying to prove that smiling leads to lenient punishment. The alternative, or excuse me, the null, which is the status quo, there's no difference in punishment. Sorry, I'm going to abbreviate here. Whether, and I'm running out of room, smiling or not. So the null is the status quo. It doesn't make a difference if you smile, you're getting the same punishment. The alternative is that smiling is going to get you a more lenient punishment. Now, if we did an experiment and we collected our data and we got a p-value of 0.20, that's pretty high. Remember, the p-value is the probability of observing the results that we did, given that there's no difference in the punishment whether they smiled or not. So we're saying, you know what? 20% of the time we saw results like this, or we'd see results like this, whether they smiled or not. Actually, I'm going to take that back. I looked at the clock and I saw I'm running out of time, so let's put this in. Given the null is true, and there's no difference in punishment whether they're smiling or not, we would observe the results that we did from the experiment, or at least that unusual, 20% of the time. Is 20% something unusual which would make you doubt the null is true? Absolutely not. 20% could happen very easily. I tell you there's a 20% chance you're winning the lottery, you're all going out and buying lottery tickets. Now let's just say that the p-value is 0.001, which is very low. Now I'm saying, given the null is true, and there's no difference in punishment whether you're smiling or not, we would see the results from this experiment, or something that unusual, like 1 in 1,000 times. It's really unlikely that we would see those results if the null is true. So we reject the null, say it's not true, and we can say that probably, because this is an experiment, smiling leads to lenient or more lenient punishment. Okay, play back this video, the parts you need, and be able tomorrow to tell me what a p-value is, what a null hypothesis and alternative hypotheses. And after you finish filling out the graphic organizer with this, or the notes organizer, feel free to write down any questions you have in your notes. See you tomorrow.